on this one, we want to set it up just like we have any other division problem with numbers or variables. Which number should go in the box? The first number or the second number? First. So I'm going to rewrite it here. X squared plus 7x plus 12, then divided by x plus 2. So the dividend divided by the divisor. Does anyone know what the answer to a division problem is called? The quotient. Good, quotient. So I'm looking for a quotient. I don't have it there. Okay. And you know what I did as I'm trying to prep up for this lesson? Again, I've taught it so many times, but I wish I had like a key to just make this easy, but I still haven't found that yet. And it's long division. So have you done long division before? Have you divided numbers where you have to divide, multiply, subtract, bring down? You've done that a lot of times. We're going to do it with polynomials, and we're going to do it, guess what, a lot of times together. Okay, what you're going to do is you want to divide the first term of the trinomial by the first term in the binomial. Does that kind of make sense? Just divide them out. And you've actually done this, hopefully last night if you did some of these problems. What's x squared divided by x? X, good. Now I'm going to put the x over here, and does anyone remember why I said put over there? Technically, yeah, let's go with that. I'm not going to give you a way out on that. Josh, why? Yeah, just, you see how the x and the 7x are like terms? You're stacking up place value, which is what we're doing here. Okay, now, I hope you could see, does x come out of both of these? Can x come out of both of these? Yeah, it's an x, that's the GCF you can almost think of. So that's why I took out the x. So now I'm going to multiply. What's x times x? X squared. What's x times 2? 2x, and that's positive 2x. So that's all I did. And hey, is that dad, what was it, dad, mom, sister, brother? Yeah, I think that's what it was. That's one acronym you can use for long division, and you can use it here as well. So what we first did was dad. What does dad stand for, do you think? We divided. We divided these two together. Second step was mom, which stands for we multiplied, and we got this. So what do you think sister stands for? So I'm going to do it like this. I'm going to draw this little subtraction sign. So what's x squared minus x squared? Anyone know? Yeah, 0. They cancel out. I just cancel them out. What's 7x minus 2x? 5x. Okay. Then brother stands for?
Bring down.
Bring down. Now, this is what we did. And again, I was trying to what can I say to make this maybe a little bit easier? Okay, we divided the first terms and we got our x. Then we multiplied to get this right here. And in a sense, you can say that x plus 2 can fit into these two this many times, but does it fit into it perfectly? No, it has a remainder right now of 5x. Then you bring down that 12 and you start the process again. Okay, what's 5x? Back to dad. What's 5x divided by x? 5x divided by x. Positive 5. Okay? Then we multiply. What's 5 times x? 5x. What's 5 times 2? So, in a sense, you can say that x plus 2 fits into 5x plus 12 this many times, but it's going to have a remainder. It's not fitting perfectly. It doesn't. So now we subtract. What's 5x minus 5x? Canceled. 12 minus 10? Okay, that's how we got that 2. Is there anything left to bring down? No. So we're done here. We're not going to decimal points. But when I have a remainder, I can write it as a fraction. Does anyone remember what that fraction is? Beth?
I don't know what it is, but I have a question.
Okay, let me get that fraction, then I'll get your question. How do I get that fraction? 3 of you know. 4, 5, 6. Come on, keep going here. 7? Someone? 7?
No.
7, kind of. Okay. How about this? On the count of 3, give me what that last part would be. Give me that fraction on the count of 3. 1, 2, 3.
2 over x plus 2.
He said on 3.
X plus 2. All right, there you go. Yes, so it's 2 is the numerator, and x plus 2 is the denominator. Just like you would in a long division problem if you left it like a mixed number. That's our answer right here. Okay, and I'm telling you right now, if you don't get this even 10%, like you're just like, what just happened here? That's okay. So far, even just your faces are not showing me that this is bad. No, I don't like this stuff. Just keep going through a process and we'll get used to it. Because I'm telling you right now, I will admit to you right now, when I learned this, I remember learning this, I was not a big fan of it. I'm like, this is a dumb process. Whoever thought of it, let's find them. But it's actually a smart process, so I was wrong on that. And it's very useful. Okay, questions or comments? Okay, question.
So can you tell me why you can do this?
So it's because of that long division process, and you're doing it's just a little harder to think of. So I kind of try to explain on that first step. Can x plus 2 fit into x squared plus 7x? Yeah. Yes, it can fit in x number of times. And that's like
long division except with
your
binomials.
Variables, terms, and all that. And it doesn't fit into it perfectly, so you have like a remainder here. Just like if you were dividing by numbers, you get, no, it doesn't fit perfectly, it's off by this much. Bring that down, try it again. It's close, but it's still off by a little bit, and then you get your fraction. So it's the same process. Yes, it's harder. I'm going to go with Beth because you were asking.
Okay, so how did you get, back to the 5x plus 12?
Okay, right here.
Yes. For the answer, how did you get 5 out of that?
Okay, what I did is I look at this term, and I do 5x divided by that term. So it's kind of like what I did here. I took x squared divided by x is right here. 5x divided by x is right here, and then the remainder. So that the same process, and you'll get used to it. It'll get more comfortable as you get practice. Yep.
Can you go look over the multiplication question?
Can I do it on a different problem, maybe? Yeah, I'll go over this again and again. Yep.
Why do you not ever multiply by the 2 or divide by the 2?
So, and this is where that process is. Technically, you did when you did x squared plus 7x divided by x plus 2. I mean, that's what you did, but you did it simply by doing x squared divided by x. So, okay, x squared divided by x gave me x. And you're like, well, what happened to that 2? Well, technically, x plus 2 can fit into this many times, but it has a remainder. Do you guys see that there's a difference between these two? So I get a remainder. So you're doing it, but you're not doing it explicitly. You are doing it, but not explicitly. That means you're not doing it directly, but eventually you are doing it.
I have another question.
Yeah. Uh-oh.
Like when you got 5x plus 12, why did you only divide by 5x? Because like if that was like long division and it was like 61, you would have just divided by 6.
Okay, so here, and again, good question. Here you divide by 5. You divide this by x, right? And you get your 5. Technically, you did 5x plus 12 divided by x plus 2 is 5. Because you get this and you get a remainder. So even though, again, you didn't directly do 12 divided by 2 or whatever, you still kind of went through that process. It's just not clear there. And that's hard. I get it. Let's keep doing it. Because what I'm going to do here is eventually I'm going to show you, okay, let's go through this process, which seems bad, right, or not right. And then we're going to go through a process that we know is correct, and they got to match, don't they? They have to match. Same problem, different methods. If one doesn't match the other, one of them's wrong. Okay. Oh, okay. Let's go through example number 2. Thank you for that segue. Do you have my notes? Okay. Example number 2. I want to go through it the long division way. Then we're going to go through it a way that we know we can do, and it can be right, and see if they match up. Because if they don't, I'm done with long division. Okay. It is 3k squared minus minus 7k minus 6 divided by 3k plus 2. Can somebody tell me how to set this up as a long division problem? So I have my box. Can anyone tell me what numbers go where? If you could do this, you're in a good spot. Yeah, Benson?
2k squared minus 7k minus 6 is on the inside.
Okay, it's on the inside. And then that means this is on the outside. Okay. Guys okay with that? All right.
Yes.
Can anyone tell me what the first step is in this problem? First step. Beth, you asked me about it on that part right there.
Yeah.
Tell me what to do.
Do you do 3k squared divided by 3?
That's exactly it. 3k squared divided by 3k is what? K. And I'm going to put that here because of the like terms. Okay? K. Insert laughter here. Okay. Okay. So you divided by 3k and you're like, but what about that 2? You'll get to that 2 in just a moment. And this is how I thought of it because, again, the explanation is kind of hard. What you're doing when you just divide 3k squared by 3k and say it's k is now you're forcing this to be divided by k. Okay, you're forcing it to be divided by k. Sometimes it comes out even, sometimes it doesn't. All right, but anyway, k times 3k. So here's the multiplication part. 3k times k is what? 3k squared. Does anyone know what to multiply next? Walker?
K and 3k plus 2.
Sorry, 3k squared, and then what do you multiply next?
Oh, sorry, k plus 2.
Okay,
2K.
k times 2, which is 2k. All right. So I just did this times that. Yes, sir.
Can you always perfectly take out the first one?
These two?
Like, what if it was like
True.
4k squared?
Oh.
You're hurting. But you're hurting for this process. There is another process. And basically, can I give you a little, I'm going to give you background to long division. And you learned it in 3rd grade, maybe earlier, a little bit earlier, maybe a little bit after. Long division is called an algorithm. Have you ever heard of an algorithm?
No.
Have you ever heard that word algorithm? All it means is this. This is all it means. It's a way to do something. So there are many algorithms for many different things, and that's just one way we use it, because there are going to be other ways. Okay, but anyway, what do I do with these two now? These two binomial parts. Subtract them. So I'm going to subtract. Anyone know what 3k squared minus 3k squared is? So they cancel out. Now here you have to be careful. What's negative 7k minus 2k?
Negative 9k.
Negative 9k.
And then for sister. Or
Now,
brother.
brother, I'm going to bring down that negative 6. Okay. Somebody who hasn't answered yet, can you give me the next step here? So I did dad, mother, sister, brother. Okay. Who has not answered anything today? Can I go with James? What do you think I do next?
Division.
Yeah, what do I divide?
9k by 3k.
Yep. Negative 9k divided by 3k is negative 3. Negative 3. Okay, go ahead, Benson.
You multiply the negative 3 by 2.
Oh, sorry, negative 3 by,
3k.
which is negative 9k. And then, that's okay. And then negative 3 times 2?
Yes.
Negative 6. And this little process here, you're going to subtract, right? You're going to do a negative minus a negative. Can you do stay, change, opposite?
Oh my god.
And if that's the case, then you get that still to cancel, which is good. And what's negative 6 plus 6? Do you have a remainder? No remainder. This is your answer.
You could do
I like that one better.
On this one, yes, you can. Be careful with that. Okay, you guys okay with k minus 3? No remainder? There's no, you could put 0 over 3k plus 2, but that's a 0. So we don't put that in. Yes, sir?
Can you do that last part again?
This part right here? The state change is opposite?
No, but before
This right here? Okay, this is from the subtraction of these two. Bring that down. And then I did negative 9k divided by 3k, negative 3. You see that part? So negative 9k divided by 3k is negative 3. And if you're like, wait, what are you saying? I'm saying negative 9k divided by 3k is negative 3. That's what you did yesterday. There's a tie into that. But that's how I got that negative 3. Harper?
Why did you do k divided by the 2 and then negative 3 divided by the 2?
Where's that?
At the top ones, the very top. Did you do the k and the 2 and then?
I did k times 3k and k times 2 to get this, and I did negative 3 times 3k, which, again, we changed the signs, and negative 3 times 2 to get those two, but I had to change the signs after.
So you always do the first and then the last?
Yeah, you do this term by both of these, this term by both of these, multiplying. You multiply them. Yes. Okay. All right, this is my answer, but I don't like it because I hate the process. So I don't want to go through that process. I want to go through the process I already know. Do you guys remember what you could do with these two right here? Could you write it as 3k squared minus 7k minus 6 over 3k plus 2? And nothing cancels out here right now. But can I factor the top? Okay, go ahead and factor it out. And don't tell me what it is. Everyone factor out 3k squared minus 7k minus 6. Don't tell me what it is. I don't want to know yet. Yeah. Thank you. I don't know. We'll find out right now, I guess. What a great question. Let's see what happens here first.
I want to see more practice.
So it is going to factor into a binomial, but into binomials. But what are those binomials? That's what we're trying to figure out. And do you guys remember you multiply using the bridge, get your 4 terms, factor by grouping, get those 2 factors. I'll give you about another minute. Go ahead, you still have another minute. Okay, Vivian, what are the factors that you got?
K minus 3 and 3k.
Oops. Yeah, sorry, I wrote it wrong. Okay, this is what you got? Anyone else get this? Factoring?
This one is easy.
Ignore all this? No, what happens here?
You cancel out the big amount of
Oh. Okay, 2 things here. Let me go into the one that maybe is not as appealing to hear. This process gives me k minus 3, and all of us can understand this, right? We get this, and it works? Same answer? This also works? Could you agree with that? This also works? Okay, but then the question that Beth asked, natural question, if we can do this, do we have to do that? The answer is absolutely not. Don't go through this if you could do that. But, so there's the big, do they all do this?
No.
So you got to know. That's no clapping on that one.
No clapping.
Okay, let's go through another one. Page 678, number 7. 678, number 7. Page 678, number 7. I'm going to write it as a division problem. And you can do it too. Okay, I'm going to call on different people to give me the parts of this process. So I'm hoping to get everyone. So if you're like, he hasn't called on me yet, I'm so relieved. For now, you can feel that way. Okay, first step. Riley, what's my first step?
T and E squared.
Say that again. T. Okay, you're going to do t squared divided by t, which is t. Okay, so I got my t. Okay, Katie, next step. Yeah, t by t. What does that give me? All right, next, what do I have to do? Lisby. T by the 7, that gets me positive 7t. Okay, Eli, next step. Subtract. Okay. Kyra, what's t squared minus t squared? Cancels out. Lizzie, what's 6t minus 7t? Negative t, or negative 1t. Very good. Do you guys notice? You try to fit t plus 7 into t squared plus 6t. You can do that, but not your remainder is not positive. It's negative because you went over it. You guys see how we went? This is over that or bigger than this one. That's why you get that negative t. You went over it. Next step here, Wyatt. What down? Negative 7 comes down. Very good. Next step. Oh, yes.
Can you do it for the negative t? Can you do
T plus 7 here? No. And that's that whole state change opposite. You can do state change opposite, but the first part is always stay. So whatever's down here can change, but not that first part. Okay. Taylor, sorry. What's my next step here? Negative t divided by t is negative 1. Negative 1. You guys agree with that? So negative t divided by t is just negative 1. Okay, next step. Hayes.
You multiply the negative 1 by the t plus 7.
Okay, negative 1 times t, negative t. Negative 1 times 7, negative 7. What do you do with these? You subtract them, which could do, you could, basically all the signs change there. Negative t plus t, cancel. Negative 7 plus 7, cancel. What am I left with? Any remainder? How many of you think you could do one on your own? You could do one on your own. How many of you feel you could do one on your own with a little bit of help, just a little bit? How many of you with a lot of help? You could get it done. Okay. So I'm going to try to cover all of those.
Yeah, we could get it done.
Yeah, that's true. But let's go with this next one. This one I want you to do. If you can do it on your own, don't look up. If you feel you can't do it on your own, don't look up. Unless you really, if you're just like, I don't know if this is good. Okay, then you need a little bit of help, look up. But try to do it with no help, a little bit of help, and maybe a lot of help. Number 8. Try it out. If it doesn't come out at all, that's okay. We'll try it again. Okay, so if you need a lot of help, feel free to stare at that board and ask questions. If you don't need as much help, occasionally glance up, see if you're doing it right. If you do not need help, just stay on your own, keep working.
Wait, do we have to do it with the taking away?
Yeah, just the long division process. Is that what you mean?
Can't do like.
No, do it long division here. Yeah, and if
Right, because I saw that.
yeah, and if you could do it the other way, that's a good check to see if your long division is going to be good. Yep.
Okay. So
Okay.
when you add with s squared and that equals s.
Uh-huh.
You put it on the line, right?
Yes.
And
Yep.
then you put it down there, like under s.
Squared.
And then what do you do with 2?
You do s times 2 is positive 2s.
Okay.
Then you're going to subtract these two. You're going to get canceled out and 9s. Bring down that positive 18. Then you're going to go through the process again. 9s divided by s, positive 9. 9 times s, 9s. 9 times 2, 18. What do you do with these two? You subtract them. They cancel out. Oh, they cancel out. You're left with no remainder. You get your answer of that. Okay, all right. I need to hear this question. Yes.
So if you have like a common
Factor?
GCF,
Uh-huh.
GCF, you just factor that out and it's like on the outside of your like final answer.
I see what you're saying. Like if this had a GCF?
Yeah, like say it's S.
If this has a GCF and that doesn't, don't factor it out. Because you could factor it out, but then you're left with some number that throws this off a bit. If they both have a GCF that's the same, factor it out. So basically, don't worry too much about GCF when you're doing long division, because it won't help you unless both of them have it.
And then put the GCF on its very end if it's both.
No, you just take it out. It's out of there. Because it's 1 over 1.
Oh, that's...
Yes, ma'am? Beth.
Okay, so I'm good until like I get to 9s plus 18.
Okay. Okay, once you get right here, you're like, okay, I went through that whole process. You do it again. You're going to do 9s divided by s, 9. You're going to go through the whole process again until you get to here. And then you could go through the whole process, but there's nothing left to do.
And then what do you do with 18 again? How did you get the plus 18?
This one? You did, once you got that 9 out, you did 9 times s, 9s. 9 times 2, 18. So you just did the whole thing again. And that's that algorithm we're talking about. Okay, I'm going to give you a tougher one. And guys, there's no shortcut.
What?
Number 9. Who's super confident on these? Uber confident. Hayes, you work back there. Josh, you work up here. Number 9. I'll give you the problem when you're up there. And Hayes, I think you need a marker. That was about that. And you have some here, Josh. I'll read the problem to you guys. So I'll read it to you. It's 2m squared plus 7m plus 3 divided by m plus 2.
Wait.
Wait, can we divide it out if we want to?
Sorry?
Can we divide it out if we want to?
No, this one you're going to have to divide out. There's no common factors to get rid of.
Yeah, okay.
So this is where like, wait, I can't do it the shortcut way. Nope.
Wait, no, it's not. Oh, I see.
Yeah, see, it could have possibly had common factors, but in this case it doesn't. Yes, ma'am. So you get long division.
So this one isn't the same as that one.
No, but you still do 2m squared divided by m. What's that? 2.
2m.
And you write that above the 7m. Go through that whole process again. Sir? Why? So you do 2m squared divided by n is 2m. And you write it right here. 2m. And then now you're going to do 2m times m, 2m times 2. Yep. And then 2m times 2, 4m. Yes, ma'am.
I got 2 plus 5m, is that right?
Oh, wait. What'd you do when you did 2m squared divided by m?
I don't know, I was just looking for patterns.
Okay, here. That's okay, and that's not bad. That's actually a good process. So 2m squared divided by m is 2m.
Okay.
Now 2m times m, 2m squared. That's how you got this.
Okay.
2m times 2, 4m.
Oh, because you multiply.
By 2m and 2, that's 4m. Then subtract.
Will those always cancel out?
Yes. They should always cancel. Now, if you guys are looking at that problem, how many of you maybe try to look for a common, like if you could break 2m squared plus 7m plus 3, anyone try to break that down? You can break it down, possibly, but will it have a common factor with m plus 2? No, it won't. So you have to go through this process. Looks like they got the same thing. So it must be right. How many of you got 2m plus 3 minus 3 over m plus 2? Okay, help or not. I just wanted you to get it. Okay, good. Good job, guys. Thank you very much. If you could do this next one, you are on a good path. This was the hardest one I've given today. Same page, number 10. This is the next one. Number 10. And you can ask your neighbor or check with your neighbor about what to do next, or you can ask me if that isn't possible in this case, for whatever reason. Oh, yes. I really wanted to go over the check, like you could check these answers, but it is complicated. But you can, it's possible, you can check it. And I'll go through that thinking process in just a bit. Oh wait, what's 3r squared minus 3r squared? Because you did 3r times r is 3r squared.
Oh.
And that
Oh,
would
so now.
be 0. Get cancel out basically.
And then still.
And let me make sure here. 3r times 15r minus and then bring it down. Yep. Yes, ma'am.
How do I do this right? I feel like I did something wrong.
That minus cancel minus bring down negative 4 minus 20 plus. No, that looks good.
Okay.
Yes.
So I'm confused with
Okay, and that's the same spot you asked me last time. So can I see your pencil? You know, what did you do on your very first step? You did this divided by that. Same thing, do this divided by that. What's negative 4. And then you're going to do negative 4 times r down here. And negative 4 times 5. And then you're going to subtract these. You can do state, change, opposite, cancel. And then that's a plus. It's 27, isn't it? But there's nothing left to bring down. So can you write the last fraction?
Yeah.
Oh. Okay. Thank you, guys. All right, I'm going to go through the process, and hopefully you went through a similar one. I do 3r squared divided by r is 3r. 3r times r, 3r squared, 3r times 5 plus 15r. But I have to subtract these. These will cancel out. And that minus that, negative 4r. Bring the 7 down. Now I do this whole process again. Negative 4r divided by r, negative 4. Negative 4 times r, again was negative 4r. Negative 4 times 5, negative 20. And I have to subtract these. I could do stay, change, opposite, cancel. I get my 27. Nothing to bring down. I keep it as my 27 over the r plus 5. This is your answer. Okay, Okay, can I give you some encouragement? Because I want you guys to realize something. Not even 24 hours ago, we went through this process, right? Not even 24 hours ago. Did you get it the first time?
Yes.
No? So some of you may. Some of you may have. Did all of you get it? Did some of you totally not get it at all?
Yeah.
Now look at it. And really, we've only spent maybe 25, 30 minutes on it, and now you're getting it or you've got it. Whether you're in the complete got it or you are getting it.
Why do we do 33B on paper?
Say that again?
Why do we do 33B on paper?
On 679?
No, let's not do 30.
Oh, you can do that. You just do 20t cubed divided by 4t.
That's not that
Gives you your 5t squared. Then you're going, it's the same process, just bigger numbers. Don't be intimidated by that. You can do that. Okay, let me give you your homework, and it's a lot, but you have a lot of time. Okay. Yeah, I mean, it's a lot, but you should be.
Can you tell us which ones we can do the shortcut?
Actually, this is what I'm going to do. You have to decide. So what you can do is this. There are two ways to do that. If you always start trying to factor them out and see common factors, you can do that. You'll find out sometimes they do have common factors. Get rid of them. You're done with long division. Or you're like, nothing can cancel out. You got to go long division. Or, my favorite, is to just do long division on all of them. You can get it right every time.
Or we can factor until it fails, and then we start.
Yeah, or you factor. Your choice. So I'm not going to tell you, but thank you for asking why. I know that's a hard answer, but not all of them need to be long division processed. 12 through 29, 39 to 45, odd. So guys, these are the odd problems, not those. Yes.
Wait, what?
Wait,
Not
grab it.
missing rows
So
are-
they only have two problems that we need to share.
We gotta have a step through all of them.
Listen up, so I can help you out. Some of those first problems, they're just the dividing by a monomial. They're not even by a binomial. So then you have to go through the long division. Yeah, so like 12 through 16 are just your normal problems, the ones you did last night, just to make sure you guys are getting them. But then after that, you could do long division or not. You don't have to do long division on all of these. But I want you guys to know how to do it. 22? So it does sound like a lot, but you have all of next period to do it and part of this period. Yeah, we have Friday. Guys, you will get a good chunk, if not all of it, done if you come into the next period. You will. I planned it out. I'm like, what can I do to squeeze as much problems as I can out? Sorry? Yeah, you do. I hope you take the right choice. Okay. See you guys. Thank you for your attention. You guys did really well.